Hello students. In this video we're going to look at our last topic in this section, in this stats course. We're going to be looking at regression analysis, which includes correlation and a very quick overview of hypothesis testing for regression, for simple linear regression. If you continue on into the second level of stats, this is where you would start from. So the example that will help us understand regression analysis and correlation is included in your course package. So it states that a researcher is interested in determining whether there is a relationship between the number of hours a student studies per week, which is going to be X, and the percentage grade they get in stats, which will be the variable Y. Consider the following sample of 7 students. Assume that both hours of study and grades are normally distributed. So in this example, we're trying to predict the grade. So the grade, the grade that you get in this stats course is the dependent variable. It is dependent on the independent variable, which is hours. Now there are probably lots of other independent variables, x's, that could be used to predict success in a course. Other dependent variables, or other independent variables could be attendance, could be a grade in a previous course, in a related course. It could be a grade you have in a high school math or English course. So there's a variety of different independent variables we could use to predict predict the success in stats. The one we're going to look at is study time. So we'd have down the left column various hours students have spent studying and the grade that they got in the course or on the exam. Coupled with this data here, more importantly, we are given this data. So this is the data of the sum of X, the sum of all the Y values, the sum of all the X's when they're squared and then they're added up, and likewise with Y. We square all the Y values, all the grades, and then we add those up. And this one is the sum of X times Y. So in the first, for example, it would be 14 times 59, 21 plus 63, then we would add up all those products. And we have to know that there are 7 students, or the sample size is 7. So on a test, I may not give you the data, because more importantly, we need this data here to actually help us work through the questions. So the first thing we want to do is calculate R. R is the correlation, Pearson correlation. It's a measure of the correlation between two interval or ratio data. The formula, if you look ahead in your course package, kind of looks a little scary. It looks like this. But if you look through that, showing no fear to stats, you'll understand that we have all these values. And all we have to do is very carefully plug in the appropriate values and make our calculation. So let's do this. So we know that the sum of x, y is 12,371 minus the sum of x, which was 169, times the sum of y, 500, divided by 7. And once again, those values will be provided to you on the exam and in the quiz and review questions. That is all divided by the square root of the sum of x squared. So that value is 4297 minus the sum of x, 169, and then it's squared, divided by 7. And then we multiply that, still under the square root, by the sum of y squared, so 36278 minus 500 squared over 7. So I'm going to change colors here. So R is going to equal, now what I would recommend, because it'll help us later on, is calculate the value for the top part of this equation. If you do that, you should get a value of 299 0.57. And of course there may be rounding differences. The bottom two numbers, 14.73 times 23.74. That gives us an R value of 0.5 or 0.857. Generally, any correlation greater than 0.7 would show or indicate a strong relationship between the two variables. So this indicates that there is a strong relationship. One thing with R is it ranges from -1 to +1. So if you get an R value that is greater than 1, positive or negative, go back in your calculation and review that. R at +1 would indicate that there is an extreme positive perfect relationship. -1 would mean that there is an extreme perfect negative relationship between the two variables. So in our example, we are left with a positive value. So if we go back to our data, we know that because it's positive, as hours increase, grades would increase. So as hours time spent studying increases, so does your grade. If the relationship was negative, that would mean that as the x variable increases, the y variable decreases, and vice versa. So that is our calculation for R. What we're going to do next is a very quick calculation for the slope and the y-intercept. Now you may remember from earlier math courses, slope and intercept and how they form the equation of a line. We're doing the same process. We're just using different variables to represent the slope and the y-intercept. The next calculation we'll do is the slope. Now you can see that this formula looks maybe not as scary as the Pearson correlation coefficient, but it is still made up of some values that we need to replace. So if you look at the top part of this equation, it's the same as the top part of the Pearson correlation coefficient. So we're just going to put in what we've already calculated, 299.57, because this top part here is the same as the Pearson correlation coefficient formula. The bottom looks similar as well. The only difference is that we're not taking a square root. So we'll show it here. It's a sum of x squared, 4297, minus the sum of x squared divided by 7. So if we get this, it's 299.57 divided by our value, 216.86. So our slope is going to be equal to about 1.38. Now the slope, of course, is, as we know, is rise over run. So what we should note here is that the slope is positive, which means that going left to right, if we were to draw, do a scatter diagram for our data, it would have it would increase from left to right. The line would rise more than it is running. So the next thing we need to calculate is our intercept. Our intercept formula, B0, is a little easier to understand from the other formulas. Basically two parts. It's asking for the total value of y divided by n minus the slope, which we've calculated, times the total of x divided by n. So this first part is basically asking for the average y value. The total y is 500. We have 7 minus our slope of 1.38 times our total x divided by 7. So if you calculate that through, you should get a value, an intercept, of 38.1. Now what we can do with the slope and intercept is create an estimated regression line. which is this: estimated y, let's make sure that looks like a y, equals the slope, the intercept, plus the slope times x. So that's the general equation. What we're going to do is put in our values. So we know that an estimated y value is equal to the intercept, 38.1, plus 1.38x. Now with that we can make various calculations. So what we have done so far, if you look back at our general question, is that we have calculated r, we've calculated the slope, and the intercept and the slope, and we've calculated or determined the estimated regression line. What we can do now is answer questions part E and F. If you study for 17 hours, what will be your estimated grade? Remember that study time is x. So 17 equals x for part E. For part F, it says if you wanted to finish a course with a grade of 75, how many hours should you study? So we know that the grade being the y value, is 75, and we're trying to calculate x, how many hours. So let's go back to our intercept. We know that the equation equals 38.1 plus 1.38 times x. In the first part, it says basically if x equals 17, what will y equal? So you put in this equation here. Let's not use yellow. Estimated grade is going to be 38.1 plus 1.38 times 17. So estimated y would equal approximately 61.6. The second part of the question was stating that if you wanted to have a grade of 75, how many hours would you have to study? So in this case, y equals 75, and we're trying to calculate for x. So if we go 75 equals 38.1 plus 1.38 x, we should be able to get our answer. So now we can see that x will equal approximately 26.7 hours. So if you want to finish with a grade of 75, you need to put in approximately 27 hours of study time. We'll continue. We have a few more things to finish up in this course, G and H. We'll finish it up in the other video.